you to know the quadratic formula right now, but a lot of you could sing it if I go negative b plus or minus. And like,
no.
Yeah, my math 8 class has made me replay that video for them, and now it's like the like theme song of that class for some reason, but they don't even need to know it yet. So like memory tricks, like songs, really help us. So we'll get back to that. Let's talk about your homework from last night, 7-1-8. Yeah, John.
Wait, so they just like ask you to just play it like every
No, now they don't even ask me to play it. Now they just start singing it and take over class, and I just sit down.
Okay.
Like seriously, they start singing negative b plus or minus, and I just sit down. Yes, he is one of them. 7-1-8, the one with our hall rental on the front of it. And guys, sorry that we're leaving the desks in rows, at least for today. I know it's a little tough for us to focus after testing, so if we're looking at each other, we'll probably try to be goofy or maybe make some poor choices, so we're just going to leave desks in rows. Sorry, next week, Monday, Tuesday, we'll be back to regular groups. You do not have math tomorrow, so there's a little reprieve for you.
Wait, so the 8-1 or 8-2-1 and 8-2.
Yep, due next week. Due on Monday.
Next week,
Yeah.
8-3-1.
8-2-1 and 2 are due on Monday. So your homework from last night, this is due on Monday. I could throw the answers up in this video real quick. So actually, let's go ahead and I'm going to scroll down and show. I got to jump past the lessons that we skipped. And I'll come back for other questions. But in case you're wanting to check your homework over the weekend for 8-2-1 and 8-2-2, we have like not, fairly representative, not representative, possibly. And then price increase versus decrease. Remember, we talked in class about an increase versus a decrease is not going to be equal. So there's your answers for 8-2-1, and I only selected a few of those problems. And then 8-2-2, so you got a box plot that you'll be making on graph paper. I think I included that one.
Kind of feels weird seeing the answers.
To a problem, like to homework that you probably haven't done yet.
Yeah.
Yeah, guys, so it's okay if you didn't do that yet, but we need to try the homework the night it's assigned, so like it's fresh in our brain from what we learned.
I barely got a try yesterday because I had 2 across.
Yeah, I feel you. We're having a bunch of Zoom calls. I mean, I know I've already told you guys, we're trying to recruit that next class. Yeah. Well, I was going to say more, but I don't need to.
That's all the information.
Yeah. We're trying to onboard people and get them to say yes. All right, no questions? I wonder if we've just had a busy week and we haven't really gotten to try this far.
92C.
92C. So I love this because we have the diagram that we've been using for a while. So the first thing that we have to figure out is if the total price is $120, what is that 25% discount? Can anyone relate 25% to me in like a fraction? What is it? Yeah, John?
25 over 100 or 2.5 over 10.
Or if we're thinking like money, it's a quarter, right? 25% is a fourth of something.
Oh, yeah.
Right? 25 over 100 would be a fourth of something. So if you recognize that 25% is a fourth, you could just do what's a fourth of 20, or if we write out this work, like we showed in class and we had on our math notes page, we can also take the decimal form of the percent and do the multiplication. We could also set up a proportion, right? So I could also say, if $120 is our 100%, how do I get to 25%? And that would be division by 4. So we divide by 4 and get that this is a $30 discount. So that's going to leave us paying how much? 90, right? So it was 120 total. I saved 25%. So if Wyatt has $95, can he afford the 90? Yeah, if you have 95, can you afford the 90? Yes. And guys, if you haven't done this problem, you can do it with me right now, as long as it makes sense. And if it doesn't make sense, ask me like, wait, what? Like, make me stop and repeat myself. So B would be yes. If there's no tax, Wyatt has 90 left to pay after the discount. So yeah, he's good. But if there's 5.5% sales tax, this can be solved a lot of ways. But what I'm going to do is 5.5% of my 90 that I would pay. So to set up that work, 5.5% as a decimal, be careful, it's 0.055. Sorry, this kind of looks like a comma. Because we move the decimal from here left 2 places times the 90 that he's supposed to pay. Let's say they realize, oh wait, we need to charge you tax. So $4, ooh, $4.95. Would he still have enough money?
Yep.
Yeah, only by 5 cents though. So that's the extra tax that's going to be added onto his 90. So his total is $94.95. All right, other questions? Farah? 95 what? Sorry?
95.
B, boy. Ah, thank you. These are really good questions that you're asking. So, based on the plot, the box plot, right? Based on the plot, what percent of students watch less than 5 hours of television each week? So, less than 5. I'm going to kind of make 5 my cutoff. What percent is in each section of the plot? 25. Because remember, this is broken up by quartiles. So if there's 25% in each of these sections, what percent when I put these together? 50. So to the left of the middle of the box is 50%. Today. Yep, you're taking the words right out of my mouth. All right, John seems to be chomping at the bit to dive into the lesson. I am too. So let's go ahead and dive into our math notes first. Actually, you know what? Let's look at the like handout paper, which I don't even have yet. So on there, it asks you to estimate. And I am just really curious on what we know about angles right now. So guys, 0 risk. I want you to go ahead and try 56 that is on your paper. Based off what you already know, which might not be very much, which is okay. I want you to try out 56 real quick. And then if you just totally don't know, you can just put a question mark there. Like, don't make something up, like Mr. Estes often says. Like, don't make up knowing something.
Can we say like more than 90 degrees?
Yeah. Yeah, or, I mean, we're trying to approximate what it could be. Guys, it's funny all the hiding places I have in my classroom.
Wait, you have hiding places?
This lunchbox is a hiding place. And these are colorful. See, this is why I wish my Math 7 classes were back to back. Because you could just leave these on your desk. Oh, we have to accommodate other classes. Social studies. Alright, so I have more of the colorful ones, but they're in packages, so I might not leave, assuming that they are where they're supposed to be. I think Mr. Smith has them. I think I gave those away. So, sorry, some of you get them. Actually, I like these better. I'm not going to lie. I like these protractors better. They're just not colorful. So, sorry that they're not colorful. So, when you look at a protractor, make sure that you can read the numbers on it. If you can't read the numbers, it's upside down. So, flip it over.
Which number is which?
Yeah, exactly. We're going to talk about this. So, there are a few students in particular that when they come into my room, when they sit back at the standing desks, they immediately, you guys might be able to figure out what I'm about to do. I look back there and they're like, which can very quickly make you get dizzy. How do ice skaters not get dizzy?
That's my question.
Spotting, you pick a point and you track it, so you move your head as you go. So what am I doing? Aside from getting dizzy, I'm rotating, right? So when we talk about angles, angles are a measurement of rotation. And angles are measured in degrees. Again, English is a complicated language. Not degrees like temperature, right? Not degrees like temperature. Degrees in the sense of angles. Now, there is actually another way that we can talk about angles in a way called radians. You don't need to know that yet. But if you have an older brother or sister and they're trying to flex their knowledge on you, and they ask you like, oh, how else can you measure angles? You can look all smart and be like, in radians, bro. And then they'll be like, well, what's a radian? And then just tell them, psh, if you don't know, I'm not telling you. That's the good way.
And then they say, oh, you don't know because you're not telling me because you don't know.
So one angle that we all like a lot because it looks nice, that was in the video that we just watched, opens up just like this and looks like a corner of a piece of paper. Sorry that there's some stuff. If I flip this the other way, it actually looks a little nicer at the corner here. If I make a corner, essentially, what degrees are we talking about here? 90 degrees. So if you want to make a little reference on your notes, I should do this at the board while I'm sitting down. Oh no, I took one of my smartboard pens home and I think I left it at home. It was in my pocket, which is not that surprising, honestly. So if you want to make a little note on your paper, a right angle, as opposed to a wrong angle, has a little indicator in the corner of it. This little box, now I don't actually like that people call it a box. That's a square, because a box is like three-dimensional, right? So this is a square telling you that this angle is square, meaning that it is 90 degrees. So how we measure angles beyond that, or how we name angles, is either if they're smaller than that 90, what do we call them? We call them cute. Well, acute, right? So we could say B is an acute angle. But if we're going to try to estimate how many degrees it is, approximately, Amanda, you want to estimate how many degrees that might be?
Oh, I get it.
Mia, you want to estimate how many degrees? I'm lost. Mia, you want to estimate how many degrees? 50 degrees? Sure, 50. Somewhere between 40 and 50, probably. And we want to make sure we label it degrees. And we're just estimating. No risk here. What about A? Antonella, you want to help me with A? What's your estimate there? It's bigger than 90, right? It's bigger than a right angle. So 100, maybe 120. Like, my guess would probably be like 120, maybe?
130.
130, maybe? So, like, I don't know, 100 something, right? So you got, like, anywhere close to, like, 120, 130, I don't know. We got to look at how to measure it. Ish degrees. I don't think that's a very accurate way to measure, but we're going to leave it for now. What about Marina? What about, I'm so lost with, yeah, okay, that's what I was wondering. I'm like, I don't think I've seen her. Carmen, what about C? No, what you might be thinking is like Hudson has lost his mind. That is not an angle.
I know what it is.
Right? So, do you want to say anything about what you think, or we got some hands up we can throw it to? Layla? Sure, yeah. So, this is 180 degrees, and it is what we call a straight angle. Which always sounds a little like oxymoron. Like, which is not like an insult, like, oh, you're a moron. What's an oxymoron? English is tough. Anyone? What's an oxymoron? Kylie, do you know?
An oxymoron is something that sounds wrong or like seems
Yeah, like kind of like sounds contradictory or sounds like, so like straight angle. When we think of an angle, we think of like an angle, two things that are angled with each other. But a straight angle, if we talk about a vertex in the middle of the line, so like some of you might look at that and be like, well, that's a line. It's got arrows on both sides. That's a line. But if we say that there's a vertex, so go ahead and put a dot there in the middle. And if we look at it opening up, it opens up 180 degrees. And guys, when I got into angles was when I was a kid, Tony Hawk, who's now like an old dude, he still skateboards, but Tony Hawk landed the first ever 900. So if you can imagine, you go off a half pipe, and this chair doesn't spin as good as the other one, but so one rotation all the way around is how many degrees? 360. So then I go another rotation all the way around. What's 360 plus 360? 720 plus another to get me back down the half pipe. Right? So if you can imagine Tony Hawk, and this is like back in the 90s? I forget that you're younger than me.
I know who he is, though.
I know who he is, she says. So Tony Hawk went off the half pipe, rotated 2.5 times, and landed on his skateboard and kept going. It was awesome. That's when I got into angles, right? So, all right, we should off my soapbox about Tony Hawk. Class, what did you approximate this at? 25. Like, 20, 15, 20, I don't know. Something. All right, so approximating angles is only so good, though. Because if I'm building something for a friend, and they say, hey, Micah, I want a hexagon game table. Because a lot of board games are hexagons. And I need to build them a hexagon. Am I just going to estimate the angles? No. And actually, and I'll show you guys on Monday because I forgot to take pictures, my saws are set up with angle measurers on them. My saws literally have protractors built into the saw. Pretty much every saw has a protractor on it, which is what I handed you, this. This angle ruler is called a protractor. So, I think I skipped past it already. I don't even know if they show it. So, check it. Let's talk about how to use a protractor real quick. I'm going to get us to our next lesson, and then I'm going to go back to our... If we look at this now, and we want to see how close we were. Grab your protractor and make sure that you can read the numbers. Now, every protractor has like a 0-point intersection, and these gray protractors, it is at the bottom of that line.
Do we put ours in a circle?
Yeah, so the colored protractors, I might need to borrow one of the colored protractors from someone to show where that 0 point is. I had one in my drawer, but I think I gave them all away. Can I borrow yours, Pete?
Here.
So the 0 point on your protractor, on the colored ones, is like literally where you can see through the hole at like where we can rotate this guy. And what is slightly nicer about the colored protractors is because my ray doesn't quite go far enough to reach my angles on the protractor. Now, you could just grab a smaller protractor. There are smaller protractors that I actually like even better. But if we angle our piece of our protractor, it's picking up 2 different numbers. Now, this is where we often get confused. Why are there 2 sets of numbers here? Well, I could be opening up from 0 over here, or I could be opening up from 0 over here. So when we look at how this angle's opening, which 0 do we want to use, the left or the right? The right, because my bottom points to the right. That's the 0 that I'm going to open up from. So I'm using that bottom set of numbers where the 0 is. And I'm ignoring the set of numbers where the 180 is. So then I rotate this around.
It's 135.
And it's actually, right between 130 and 140, probably about 135. So if you want to, under this, you could write like actually 135 degrees. Go ahead and try to measure the other ones on your paper. You were super close. My gray one's the only inconvenient thing is I kind of have to imagine where the line will hit. Or if you grab something else that is straight, like another pencil, or like I've just got these little pieces of scrap wood over here. Which set of numbers are we using? Well, the one's less than 90. That's the other question you can ask yourself. Is my angle supposed to be more than 90 or less than 90? B, we said, is for sure less than 90. What do you measure B to be? 40? Yeah, like 45. So the actual for B is like 45 degrees. We already know that C is actually a straight line, so hopefully you put a vertex here. And then D, I don't know why it looks like mine kind of copied sort of twice. Does your guys have a shadow on your paper too? My paper sort of has like a weird shadow at D. But this is weird because there isn't one flat on the bottom. So rotate your paper, line up your protractor, see where that other ray would hit. How big's it look? 20. I think it's like straight up at 20. So I think the actual for D would be 20 degrees. Questions on how to use that protractor. You line up your 0. Now once you think you've got your angle, double check with yourself, is this the right size that it seems like? Because with my 45 degree angle, guys, if I line this up and if I'm in a hurry, and I just, okay, where does this go? And I'm like, oh, it hits at 145. Now here's the other trick. Careful. Between 130 and 140, you have to figure out, is that 135 or 145? But either way, that's wrong. Because I know this is an acute angle. Right? So you should always be thinking. Don't just this tool can't just be trusted. We have to think. Right? The tool doesn't do the thinking for us. Are we less than 90? Are we more than 90? Questions? When I push my glasses up, I feel like a nerd, but that's okay, because nerds rule the world. All right, so now, wait, what? If I tell you you're not allowed to use a protractor, if I tell you this tool is not to be trusted, now it is, you can trust this, but if I tell you that you can't, that these pictures are not to be trusted, maybe that's what I should say. The pictures can't be trusted, the math can. There are special angle relationships that I gave you in your notes packet. So pull this, this should be out, but if you put it away, pull this out and get the angles page. So here are all your types of angles that we just talked about. We do not need to read through that top part. What we do need to highlight and make notes of, some important vocab, the vertex. Guys, I know there's a lot of writing here. I tried to trim it down, but if you don't exactly, if you're not comfortable, you need to be able to read and learn more, right? So if you're not comfortable with angles, this is how we get comfortable. Point B is the vertex, because it's where the angle is, right? Point B is the vertex, because it's the corner of the angle. I think there's an extra set if we lost it. I think over there should be. Then, so if you walked into the room and I was like, John, your hair looks great today. Kate, love that sweater. Eli, Star Wars shirt, my man. Awesome pants, Layla. Those are a throwback to the, and I just start throwing out compliments. And I'm just compliment. Is that good or bad? Is it nice or mean? Nice. It's nice, right? So how I remember this is to compliment someone is the right thing to do. Complementary angles together form a right angle. So complementary angles, guys, the other thing that really means is they complement each other because then they look nice. So complementary angles form a right angle because that looks nice. So guys, up here has an example of if I add this angle with this angle, we create a right, and it looks good. But also, these two angles down here, the 40 and the 50, what would 40 plus 50 make? 90. So these are also complementary angles. So you might, like in the same color that you highlighted, complementary angles, together they form a right angle. Now, that has to be more than one angle. So a right angle, just a right angle, is just a right angle. But if you have two angles making a right angle, that's complementary. So guys, like a picture frame, right? The corners of a picture frame, when they come together, make complementary angles, at least if it's a square or rectangle frame. Okay, you with me? We're moving on. Supplementary angles, I don't have a real clever memory trick for that, except where you take supplements to get bigger, not steroids. Kids often confuse this. But supplements, like vitamins or like protein supplements or things like that, if you like go lift a lot of weights or are trying to build a lot of muscle, you take supplements to get bigger. Now, here's kind of my funny way to remember it. Have anyone been to the Arnold Fitness Expo? So if you go to the Arnold, you'll probably see some weightlifters that are like real muscular and they kind of can't put their arms down because they got so much muscle. To remember supplementary angles, I kind of think of like a weightlifter that his arms are so muscular, they're straight. They're like, from here across is like a straight angle. Whatever helps you remember it, supplementary angles together form a straight angle. So, EFG up here plus GFH, those would be supplementary. Or, what's 120 plus 60? 180. So that would form a straight angle. Now we're going to practice these, but right now before I move on, questions on complementary or supplementary. It is multiple angles that add together to either make a right angle or make a straight angle. Trying to make sure we all have time to highlight, so I'm kind of taking a pause. Then, your neighbor at your house, if you have a fence, this is a really easy way to think about this. Sorry, I said the bad word. Angles that are adjacent share a fence. They share a ray. They literally are up against each other. So my property is right up against my neighbor's property. We have a fence between us to keep our dogs out, but both of us share that same fence. It's not like I built a fence and he built a fence. That would be silly. So adjacent angles have a common vertex and share a common side. And we'll look at this, have no interior points in common, meaning the one angle cannot be inside the other angle. The one angle cannot be inside the other angle. So these images up here, these show adjacent angles because they share this side between them. They share that same vertex, right? So right here, they share this side between them. They're right up against each other. They're like next door neighbors. But then we have some not adjacent because they have separate fences and they have space between them. So I know, especially when I ride my bike like up through the hills, some neighborhoods might have like a sidewalk to get to a park. Or if you live over like near Hard Road Park, I know there's like, so somebody's property might have their fence, somebody else's property might have their fence, and there's like a sidewalk in between them. Oh, yeah. So that space in between makes them not adjacent. Not adjacent. Sorry, I can't really write sideways apparently. Now, the easiest way for me to get you to remember vertical angles is something I always tell you guys not to do. Are there two rulers back there, Layla, of the plastic ones? sure hope so. I don't know where my rulers went. So, this needs to go on my list, and actually in the fall you guys can bug me with did I make it. I keep meaning to actually, and my classroom's full of stuff, so this is the problem. I keep meaning to make this like out of wood so it's easier to see. If I do the helicopter thing that all of you guys love to do, but if I turn it sideways and I look at the top angle and the bottom angle, and I say the top angle is not big enough, I want to make it bigger, what happens to the bottom angle? It also gets bigger. What's happening to the left and right angles at the same time? They're both getting smaller together. Vertical angles are opposite angles that share two straight lines. So I've indicated this on your paper of like C and G are vertical with each other because we have two straight lines, right? So we got two straight lines. Two intersecting lines. Now here's the thing though. Every set of two, if there's only two lines that cross each other, like we just saw, create two different vertical pairs. So C and G are vertical with each other. C and G are vertical with each other. What other angles would be vertical with each other? In that same image. What other vertical angles do we need? F and D. So if you want to indicate that in the same color. Now, what relationship would C and D have? What relationship would C and D have? It's up here on your paper. Together they make a straight line.
Oh, I don't know.
Straight line is supplementary.
Yeah.
Straight line, right? They make a straight line together. That is supplementary. So C and D are supplementary, but C and G are vertical. So I think I got like 5-ish minutes left. Go back to your homework paper. And now, who what? Try these problems. Turn to a neighbor if you want to. And like C tells you complementary, D tells you supplementary. I'm going to find this in my slides so I can actually go back to the board. Oh, there's the protractor pictures I was looking for. These are examples of incorrectly lined up protractors. All of them except for D is finally correct, except for it's not 60 degrees. They read the wrong degrees. So I go ahead and try to use those special angle relationships. This is what happens when I try to cover 2 lessons in a day. What up? I don't know that I can do anything to fix that, so you can use one of these if you want. But we're not measuring. Remember, we're not using the protractor for these. Now we're using the special relationships. So I'm going to chalk this one up to Layla doing this on purpose. Thank you, Layla. To point out that we're not using protractors. Layla wanted all of you to know we're not using protractors. We are using special angle relationships. Just take it. Just take the win. Take the win. You did this on purpose. Just say you did it on purpose. So, what is this? That's a straight angle. It's a straight line, but it's got a vertex in the middle of it, so it's a straight angle. So put together, I know that angle 1, which they tell me is 75 degrees. And it might help if you draw, like, right 75 on your diagram. Plus, angle 2 will add up to how many degrees? 180, because 180 is a straight line. So how many degrees does angle 2 need to be? 105. Angle 2 would be 105 degrees. And if I was you, I would highlight the straight line to pay close attention to, oh, that's why. Together, they have to make 180. Questions on A? Do you remember how long we're in here? Is it 30?
30.
Just 30?
Yeah, just 30.
Okay.
Yeah, 30.
I'll use cards, but guys, you're welcome to pass. I know we're still brand new at this. You're welcome to pass. Cade, what sort of special relationship do we see with angle 1 and 2? They're intersecting lines.
Yeah.
Flip back to your notes page if you can find it quickly, or you can pass. It's at the bottom. It's the bottom one. Starts with a V. Vertical! Because they're opposite each other with two intersecting lines. What relationship do vertical angles have? And guys, it's at the bottom of your notes. This is the practice page. But at the bottom of your notes page, in bold, look at what it says. Right here at the bottom, in bold, vertical angles always, what? Anybody? Have equal measures. So if 1 is 55 degrees, 2 is 55 degrees. Questions? Eve, what did we say complementary means?
I read it, but I can't find it.
You're good. It's all. If you want to pass, that's fine. Or you can look at. Oh, they didn't give us the little box, square, I should say. But if you want to pass, totally fine. Together they form a right angle. How many degrees are in a right angle, anyone? 90. So guys, if I was you, I would add the little square. Add the little square to the drawing to remind yourself they add up to 90. So if 1 is 27 degrees, I need to do 90 minus 27. Be careful that we borrow. People forget to borrow. It's not 73, it's 63 after we borrow. After we borrow, it is 63 degrees. You gotta have the degrees, guys, otherwise I need a stamp that says like dogs, cats, pizza, question mark. If you don't label it, we don't know what you're talking about. We need degrees. Angles 1 and 2 are supplementary. Anybody, what's supplementary add up to? 180, so you can make yourself a little note here if you want. And I can't fit my degree symbol really. So if 1 is 30 degrees, what does 2 have to be? Anybody? 150 degrees. And barely in the nick of time, that is all that we have time to do today. Guys, when you're doing your homework, you should be looking at your notes.
And I finished the homework.
When you're doing your homework, you should be looking at your notes. Thank you very much. Have a great day, guys. Good work on getting through ELA. Protractors, you can drop on the front table if you would. They go in my Einstein lunchbox, but it's probably going to get very full pretty quickly. And then we have other angle measurement tools like this. Kind of cool. Yeah, see, they want to fall over, and that's the problem. What's my favorite angle? Whatever angle my pizza is sliced into.
Mine's 25. That's the best angle for shooting stuff.
For trajectory? So if I do a lesson where we have to like launch things, you already think you know the answer that 45 is the best?
Yeah.
Is it always the best?
Not always. Most of the time when it's the hardest.
That'd be curious to test out, right? Like I'm not sure. I'm not doing the teacher thing. I'm genuinely like, I don't know. Is it always the best? Here, but hold on just a second. Is it similar to this? Well, this is what I have to do the launching activity from, because then this will hold a rubber band or whatever, and we can pull it back and keep track of how far we pull it back. And obviously, a lot of people will pull it back this far. All right, I will see you guys tomorrow or later potentially. Is that your book under there?
Yeah.
Awesome. Just want to make sure you didn't forget it. Rogue Protractor. Have a great day, Kylie. You know what's funny? Even though you have the same last name, I had not yet thought about you being Lynn's sister. Like I had not. I just think about you as Kylie. It's just funny.